guys, welcome back. This is Krishna again, and today we will talk about Softmax activation function because we were talking about activation function in the series. Means last time I talked about activation function. So this time also I'm going to talk about activation function, a new activation function I'm talking about, which is Softmax. Now, what is Softmax and why we are using this? So Softmax is, you can say, more or less like a sigmoid function. I can show you when I will show you the uh, use case of Softmax. You can relate that Softmax to sigmoid also. Okay, so it is very much similar to sigmoid, but there is a little change. Now, what that change is, we will talk about, and for that, let's go to Google Colab Sheet. So yesterday I mentioned all concept available we have to go through, which is available in neural network. So in that I mentioned everything, and I was talking about activation function. So this is our activation function where I talked about sigmoid function yesterday. Today I'm going to talk about the topic 5.2, which is softmax for multi-class classification. So hold on, I have something to mention here as well in sigmoid. So yesterday I told you guys like it is used for binary class. Binary class means where we have two classes in the data set. Let's say I have a data set where two fruits given, apple and banana. If somebody will ask me to train a model, and if I am going to train a model using neural network, I will use sigmoid in the outermost layer. So I use sigmoid in outermost layer because I need probability of both the classes. But one more thing you guys have to remember, it always tell the probability of positive class. I also shown you these things yesterday. So if you didn't go through my video, please go through my video, actually the whole playlist, you will get the idea about it. Okay, and now today I will talk about softmax. So here is the difference only, it is for multi-class classification. So what does that mean? See, just now I told you guys like suppose if I have two fruits in a data set, let's say orange and banana. So in that case, I will use sigmoid. Means there are two classes only. First one is orange and the second one is banana. Okay, so in that case, if I will get such kind of scenario where I have two class only and I have to implement what? Classification. So in that case, I will use sigmoid at the outer layer, outermost layer of neural network. Okay, now let's say this time I have three fruits, okay, in a data set, or more than three fruits in our data set. So just let me draw a picture for you guys. So it looks something like this. Let's say I have a data set which is looks something like this in the tabular form, where I have two feature x1 and x2, and this is what? Target, or you can say fruit name. Okay, so here I have two classes. Let's say here it is giving x1 is width, okay, and x2 is height. All right, so width is, let's say, something 2, and height is 2.1. It's in centimeter, you can say, or inches, you can say. It is let's say 2.1, and it is 3, okay, and it is, let's say, 1, and it is 5. It is 2, and it is 10. So see, these are orange, okay, because orange width and height both are same because it has a round shape. Okay, so this is also orange. This is also orange, but see, width is less, but the length is as compared to width, it's too much, right? So in that case, it must be some sort of long fruit, which is called banana. And this is also like width is 2 centimeter or inches, you can say, and height is 10. So in that case, it is also banana. So suppose I have a data set. fruit data set. Okay, and in fruit data set I have two class only. How many classes? So there are two class. First one is orange and the second one is banana. Okay, so here I will use Softmax if I will train a model using neural network at outermost layer. Okay, so suppose if I have three layers, so this is called input layer, the first one, this is called hidden layer, and this is called output layer. So at output layer I will use sigmoid. Why? Because I have two classes, orange and banana. All right, so similarly, let's say I have one more data set. I know I'm creating picture on this, but just try to understand. Okay, if I'll switch my screen multiple time, it will be confusing, and that's why I'm creating images on this screen itself only. So again I have, let's say, two feature, let's say, and this is also fruit data set, but here we have three classes. Data set, I'm sorry, the spelling is not correct, but try to understand this, guys. So it is like it has like three classes or more than three classes. So for now I'm just taking three classes. Let's say I have a data set where I have three classes only. Three classes means three type of fruits. So first one, let's say orange again, banana, and the third one is, let's say, cherry. Okay, so orange is again just picking the same value which is available here, 2, 2.1 and 3.0. These are orange. Okay, I'm just mentioning O for orange, and again picking same values of banana. Okay, so this is banana, I'm representing it by B, and 2, 10, and I can say banana again. Okay, now let's say I have one more classes. I'm sorry, this box is a little smaller, I created, I'm sorry for that. Now let's say cherry size are very tiny, right? So that means it has, let's say, 0.5 and 0.6, means it is also circular. So I have 0.5 and 0.6, two values, because it is round in shape, and this is called cherry. Let's say I'm representing it by C, all right? And it is, let's say, 7 and 0.6, it is also cherry. So now I have three classes. So that means I have, if I will create a neural network, so this time again, I have to, let's say, because I have two features, I will create one input layer where I will mention two neurons to accept these two input, and this is my neural network. But now it will look something like this. All right, so what happened in this case? So simply because I have three classes, right, and these are my feature x1 and x2. This is my first feature, this is my second feature. I will pass it here, okay, at input layer. So this is called input layer, this is called hidden layer, and this is called output layer. Okay, now what happened? So if I will pass my feature to these neuron, and it will go through this hidden layer as well, so it will definitely reach at output layer. So when it will reach at output layer, I will not use sigmoid now. I will use uh, softmax. Why I will use softmax? So basically softmax return the probability of all classes separately. So if I will use softmax at outermost layer, it will give me probability of first class, second class, and third class, okay, in a vector, which is something look like this. Okay, here it will, let's say, mention about the orange, the banana, and cherry. Okay, so it will give me the probability of all three classes, and if you will sum up these all probability, you will get 1. Okay, which is nothing but 100% probability I'm talking. So basically 100% probability is split into three parts, and the probability of whatever class should be higher, that should be the predicted value. Okay, suppose probability of orange is 70%. Okay, probability of orange, let's say 70%. Okay, because this is orange, this is banana, so probability of banana, let's say 20%, and probability of cherry, let's say 10%. So which probability is high? Orange probability is high, of course, because it is 0.7. I can see the value, and which is 70%. So the predicted value should be orange. Okay, now what is the benefit of using Softmax? So Softmax actually predict the value of each class, okay, in the form of probability. Okay, so whenever you will calculate or add these all probability together, you will get 1, which is nothing but 100% probability. So this is quite good. Okay, so whenever you have more than two classes, you can use Softmax there at outermost layer. Now how it will work, I will let you know. Okay, so moving ahead, I hope you guys understand about this, like what is uh, binary or sigmoid and what is Softmax. So once again, I just want to conclude this topic, and that's what I'm telling you. Sigmoid always use when we have two classes, okay? And Softmax we use when we have more than two classes, okay? Keep this thing in mind. In sigmoid, we only calculate the probability of positive class, which is also represented by P1, okay? And in Softmax, we calculate probability of all classes. See, the probability of all classes it is calculating. So what I'm saying, you just make a note of it, okay? Because interviewer always ask these questions. Okay, these are very basic question, and trust me, whenever interviewer asks you any kind of question, they will always ask the simplest question ever. Okay, and most of the people not able to answer those questions, and at that moment only interviewer reject them most of the time. All right, so hope you guys understand these. So keep this thing in mind and make a note of it, so you guys will get help with these kind of information in your interview. So guys, moving ahead, I'm just cleaning the window. Let's move to Softmax. So I'm just copying this thing, okay, scrolling it down, and I already mentioned Softmax activation function here, but because I mentioned 5.2 there, and that's why I'm also mentioning it here, 5.2. Now, this is 5.2, and this is 5.1, okay. Sorry for yesterday, I didn't mention that 5.1, but today I will definitely mention it. And yes, this is our, so yeah, see, today I will talk about this, okay? So now coming to the topic of today's session, okay, so that is 5.2 Softmax. 5.2 is nothing but a number which I already given in the talk file above, okay? So now Softmax, I will start with a definition. Okay, so I already told you most of the thing, but still, because this is a procedure that we have to follow. So definition is something like Softmax transform the raw score, or you can say logit. Now what is logits? I will let you know about it. It is nothing but a kind of score. Okay, so raw score, it's simply we can also say it logit. Most of the time people used to speak in interviews also, like what is logit in Softmax, what is their use. Okay, so such kind of question they always ask. So after that, if I will I'll mention the Softmax transform the raw score logit into probability that sum to 1. Now, this is very concise kind of definition. Let me explain these definition first. So here, the Softmax transform the raw score which is logit, into probability that sum to 1. Okay, so first of all, I would like to tell you what is logit. Okay, so let's say I have a neural network. I'm explaining right now this term logit. Okay, so this is my neural network. Okay, and at outer I have 3 class because I talked about orange, banana, and cherry. Okay, now when we pass, when we were training this model, okay, it something connected with each neuron like this. Okay, at this age also, each neuron properly connected with their adjacent neuron. Okay, see, now this is our x1 feature, this is our x2 feature, which I will pass. Okay, because I have shown you the data set. This is called input layer, this is called hidden layer, and this is called outer layer. Okay, now I told you this is our weight W11, W21, W12, and W22. Okay, here we have bias B1 and here we have bias B2. All right, now each neuron has 2 part, summation part and activation part. Summation part, activation part. Okay, here we also have summation part and activation part. Summation part, activation part, summation part, activation part. Okay, now here let's say I'm using except Softmax. You can use any activation function here like ReLU, sigmoid, which I have taught you earlier, 10H, leaky ReLU. Okay, but you cannot use Softmax at hidden layer. Keep these things in mind. You can never use Softmax at hidden layer. Okay, never use this Softmax at hidden layer. Okay, it always use at outer layer when we have more than 2 classes. See, we have more than 2 classes. We have 3 classes right now: orange, banana, and cherry. Okay, and it simply returned the probability of all classes. Okay, so let's say this model has been trained. Okay, I trained this model. Okay, now I have 2 feature, okay, which is 0.6 and 0.7. I created a data set. Okay, I created, just to show you last time, a data set which has x1 and x2 and their target, means fruit name. At very bottom of this table, I mentioned 0.5, 0.6, which was cherry. 0.6, 0.7, which was cherry. So can you see somewhere in this graph matching to this kind of feature? Yes, of course, we are getting that. But this is what? This is neural net. Okay, this doesn't copy paste each and everything from the data set. Okay, it simply try to get the pattern. Okay, and how it get the pattern? Using some calculation behind. Okay, so what is that calculation? So that is called logit. Okay, logit is nothing. I already taught you about the logit. Logit is nothing but the summation part, and summation part is what? Equation of line. Okay, so this x1 multiplied to this w11 plus this w21 multiplied to x2, w21 multiplied to x2, and there is a bias also b1. It will return a logit, means equation of line. Simple. Okay, logit is nothing but equation of line. Now here on this I will implement let's say softmax for now, because I'm at hidden layer, so I will use sigmoid for now. Okay, and that sigmoid function basically transform the logit, means straight line, into some sort of deviated line. Okay, just to get the pattern, okay, from the data set. Further provide this output. This is a kind of output of hidden layer. So this output further supply to each neuron at the output layer. Okay, now what will happen here? Again, it will again calculate some sort of logit. So this output further provided from this neuron to all other neurons. Okay, and it has some weight W31, W32. Okay, because I have two neuron which is supplying to this. Okay, so it will simply give whatever calculation, whatever integer value or floating value I will get from here, because if I will solve this equation, okay, I will get a single value. Okay, so that single value further passed to this logit. Okay, this summation part. Okay, and this summation part basically use W31, and whatever output it is getting from here, okay, it will simply combine with this. Okay, output. Okay, so let's say this is output 1 plus, and this is what W32. W32 will also provide me some output 2. So this output 2 will combine with W32, and there is also some bias B3, let's say. So that bias will added here. Now, so at outermost layer here, this is our logic, and I will simply apply the softmax to it. Okay, again, this is softmax 1, let's say. This is softmax 2. Again, here I will get some sort of output. Here I will get some sort of output, and I will calculate the probability of each output here. Okay, and that output simply return in a vector which is in the form of orange, banana, and cherry. So let's say here I'm getting some sort of output, let's say 0.7. So it will return here 0.7. It will return, let's say 0.2. So it will be here. And if I will return here, let's say here it is returning 0.1, the probability. These all calculate probability. Okay, these all calculate probability of all the classes. There are 3 classes. That's why we have 3 neurons at the outer layer. Okay, because each neuron is calculating probability of each class separately. Okay, so again, the maximum probability will be our predicted class. Okay, so it is indicating to this orange, and orange will be the output. Okay, so now in this case, this is something look like cherry, right? So it must belong to cherry, right? That means cherry probability should be high. Okay, so what will happen? How we will calculate? Let's calculate it. Let's say ZO is orange. Okay, this is orange. ZB is banana. ZC is cherry. Okay, now what is the formula? That is important. So what if I will show you something like this? E to the power Z0, e to the power Z0 plus e to the power ZB plus e to the power ZC. Oh, it is quite tough. No, it is not tough. Hence, it is the expanded form now, so it is not tough. The tough part I will show you. The tough part means how it represented on mathematical books. I will show you that. J E X I upon, means it is in denominator. So here we have EXI. Okay, so this is the formula. From this formula only this formula derives. Okay, means this is the expanded form, this is compressed form. Okay, now I want to calculate the probability. Okay, so let's say here, okay, here I'm getting some sort of logic. Okay, so that logic provide to these equation, okay, and we simply calculate probability of each class likewise. Suppose I want to calculate the probability of ZB. So what I can do, ZB is equal to e to the power ZB upon e to the power Z0, e to the power ZB, e to the power ZC. Okay, this is to calculate the probability of banana class. Similarly, I have ZC. Okay, I want to calculate the probability of ZC, right? So I have to mention ZC, e to the power ZC, e to the power Z orange, e to the power Z banana, e to the power Z cherry. Okay, so this is for third class. Now these all mathematics work similarly like other mathematical operation work. You have to simply replace the value of e. So you have to simply replace this this e by Euler number, which is 2.71828. That is the Euler constant, okay, which is approximate value, not precise. So you will mention the value of e everywhere, 2.71828, okay, and you have to further pass the logic of each class, which is Z orange, Z banana, Z cherry, okay, and you have to simply keep those value in this formula, okay, to get the probability of each class. See, something like this. So whatever output you will get, that will be the probability, okay? That will be the probability of that class, okay? And it will simply return in a vector, which is P orange, P banana, and P cherry. Now you guys will ask me, how can we do this? So let me clean the window and I'm going to do the calculation now, okay? So let me make a heading of it. See, suppose my Z orange is 3, logit is 3, okay? Z banana logit is 2, okay? Z cherry logit is 5, okay? Now I want to calculate the probability of each class. So E is equal to 2.71828. Okay, this is the probability of a Euler number. This is what? Euler number, Euler constant or Euler number you can say. So this is approximate, not precise, okay? Now, the formula I'm just going to mention manually for now. So it is something look like, let's say I want to calculate the logit of the probability of Z orange. So what I can do, I have to mention their E and their power, which is Z orange, okay, because this is in power, and I have to mention a bracket again. It will look quite complex, okay. I'm going to mention let's say 2 E to the power Z orange plus, but see, I have to mention these things inside bracket, okay, because we are writing in the same line, no, so we have to separate them by bracket, okay. So because I have 3 values in denominator and they all will combine together, so that's why I use additional bracket at outer layer, okay. So this is the way how we represent some mathematical formula or equation in Python, okay, or any programming language. So E to the power z banana. Okay. Similarly, e to the power z cherry. All right. Now, if I will run this, I will get probability of orange. See, I'm getting probability of orange. Okay. Now, if you want to get the probability of, this is what? Probability of orange, right? So I can mention here probability of orange. How I calculate it? Using logit. Okay. Here you have to mention a comma, and now it will mention probability of orange. Similarly, if you want to calculate probability of banana, so you have to mention here banana. See, because z banana you have to keep on the top in numerator, and rest should be the same. Okay, you have to simply calculate here or print it, probability of banana is, you have to simply mention the probability of banana, and it will give you probability of banana. See, probability of banana is 0.04151 and so on. All right. Similarly, you want to calculate, let's say, probability of cherry. Look, I'm doing it manually for now, but not further I will do like this. Okay, I'm just teaching you these concept. No, that's why I'm mentioning these all stuff uh into a manual way. Okay, but I will not show you these thing each and every time like this. So I have to mention here cherry. Okay, and that is there. So let me mention here cherry as well, because I'm calculating probability of cherry. Oh, one more thing I have to do, cherry I have to mention here. So it is nothing but you're getting probability of all the three classes. Okay, and if you will add these all classes, you will get one. Okay, so this is the probability. Okay, now most of the people simply add them. Okay, simply add them like a probability of cherry plus probability of banana plus probability of orange. So if you will add them, so you will get probability which is equal to 1. Okay, see, I add everything and I'm getting probability that is 100%. Okay, that is 1. So this is how the model work or the activation function work at output layer. So at output layer, it simply calculates the probability of all classes, and that's why I mentioned 3 neuron at outermost layer. See, I just want to show you that image again. This is that image, and we are simply calculating probability of each and every classes. Okay, let's say this is calculating orange probability, this is calculating banana probability, this is calculating uh, cherry probability. So it is simply returning probability of all the classes in a vector, you can say. So let me remove this again. Oh, 1 second. So now you guys will ask me how it will return in an vector. So simply there is nothing like that. It simply use a TF constant, and it will return everything inside it. Okay, and it will return you probability of orange, probability of banana, probability of cherry, and you have to pass it inside a parenthesis because you are using a function which is TF constant. And one more thing, you have to import TensorFlow as TF, and you will get it. It is simply importing that because it's a huge library. Okay, so it is importing that. See, I'm getting this array. It will return something like this. So see, it is the maximum probability, and it is at some index. Okay, that is 2. It will simply give the probability of that class which is available at index 2. Okay, so how it will understand? So simply in machine learning, I told you, like we can get unique values unique values in each row of our data frame. Okay, so let's say this is target. Okay, and inside we have, let's say, multiple classes. Okay, so I need all the unique classes, so I simply use unique value method, and I get a list where it will mention something like this: orange, banana, and cherry. Okay, means it will not return this, but it will always return all unique values in that of that column. So you will get such kind of unique values, and now you guys have to map yourself, like if it is on second index, you have to map this vector with this, okay, using some Python logic. Okay, so I will show you once I will apply softmax formula in future. I will definitely show you. Okay, so don't worry for that. Now I would like to tell you the last concept of this. Okay, there are many concepts, okay, inside this. I will let you know, like a gradient. I'm not teaching you for now because these concepts are very tough for now. Okay, but once we will proceed in this lecture, I will definitely teach you about gradient. I will I will also teach you like how to calculate a gradient, how to calculate derivative. Okay, I will let you know everything. So I'm talking about disadvantage. Okay, so disadvantage is, means there are multiple disadvantages, but which is you guys can understand. For now I'm going to tell you that. So it is computationally very expensive. Okay, why? What does that mean? Computationally means, so think about it. Let's say I have 100 classes in a data set. Okay, and in that data set I have 1 million data samples. Okay, 1 million features. Okay, I have a data set where I have two feature, let's say x1, x2, but classes are 100, and total sample inside these classes I have 1 million. Okay, 1 million. Okay, so 100 classes, okay, means unique classes I'm talking about. Data samples are 1 million. Okay, data sample are 1 million, not 100 million. So 1 million data set only fall under this 100 classes. Okay, that means there are unique 100 classes available in this column. But think about it. If we will do some prediction using a model which is trained using Softmax, so Softmax have some formula which I have just shown you, which is e to the power z0, e to the power z0 plus e to the power z1 plus e to the power z2 plus e to the power z3. Okay, and so on, e to the power zn. It is very much expensive to calculate for a machine. Okay, and that's why it also becomes slow a little bit. So this is the disadvantage. Now what are the advantages? So advantages are many there. Okay, if you have more than two classes, you can use Softmax. If you have a, let's say, if you want to get the probability of each class, okay, so in that case you can use a Softmax. Okay, Softmax use that outermost layer only, okay, to get the output. So these are the advantages of this. Okay, computationally it is expensive. Expensive means it will take more time, more memory, more RAM. Okay, this is the meaning of expensive. Okay, more time, more memory, more RAM. Okay, so this is called expensive. It is computationally expensive. So I'm just concluding this part on the same. Okay, and hope you guys like this. If you really like this, please do like, share, subscribe to this channel, and let me know if you have any query in the comment section. And please do share, subscribe with your friend and family. It helps us to get inspiration to make more and more videos. Okay, to put effort, a lot of effort. And one more thing, guys, thank you guys to give me like 1000 subscriber. Okay, I'm getting 1000 subscriber this evening only, and I'm very much happy. And you guys really show your efforts in this, and I'm very much thankful to you guys. Thank you very much, guys. Thank you, and keep learning. Thank you very much.